if A is a set, it might be empty, it might have elements, it might actually have some elements, but it's not the same thing as the set that contains A as its element. This is a collection of sets, right? It's a set that has as its only element another set. Right? Does this kind of make sense? No, doesn't make sense. Okay. Think of a set as a bag. All right, you've got stuff in the bag. So here I have, and let's say A is the set. It's a bag with one apple in it. Okay? This set is a bag which has inside it a bag with one apple in it. The element of this set is a bag with one apple. This set is a bag with one apple. Right? So the set is the bag and the stuff in it, as it were. Okay, so this set contains a bag with an apple in it. So it has this as an element. Okay? This is not a subset of that because, because it's an element of it. It's not a subset of it, right? It's not itself the kind of things that are collected here. Well, I mean, you can think of an element of a set as being a subset of size 1, but it's a slightly different notion. So in this Russell Whitehead notion of building up mathematics out of the empty set, this is an empty bag. This is a bag that has an empty bag in it, right? There's something in it, an empty bag, right? This set is a bag that has in it an empty bag, and then a bag that has inside it an empty bag, right? So this is two bags. This is one bag inside another bag, right? There's three bags inside, but you can't tell them apart, right? The empty set there's only one empty set. So you can't put the empty set in the set twice. It's already in once. It's in forever, right? There's only one of them. So what makes this element different from this element is that this is a bag around a bag, and this is just a bag. Okay.
So that has two elements?
This set has two elements.
So you only go down one level. You don't care what happens.
Well, what are the elements of the set? This is one of the elements. This is another element.
Okay, so you only go down one level. You don't care what's inside those elements.
Well, they might. I mean, this happens to be a set of sets. Those sets have elements, but this set is not the same as this one. These are two different elements of the bag. Okay, this sort of doesn't really make sense because in a set, if it has the empty set in it, that's it, right? It has it in once. It's sort of like it doesn't make, if you're in the classroom, there aren't more copies of you around, right? There's sort of just you. All right, does this kind of help? Yeah. Sorry? Three, yeah, so 3 would be, what are the three elements? We have the empty set, we have the set that contains the empty set, and we have the set that contains the set that contains the empty set. Okay, we have an empty bag, a bag that isn't empty, it contains an empty bag, and another bag that isn't empty, it contains a bag that contains an empty bag. Okay. Okay, I mean, this is weird, and you're not expected to know it or whatever. This is just cultural stuff, but it maybe helps you think about what's the difference between a set and the elements of the set, or a subset of the set. So the empty set is a subset of every set, right? But in this case, a subset of this is this. This is a subset of this set. It is this element, right? It corresponds to this. The set that consists of the empty set. The set that contains the empty set. Okay. So this is a subset of that.